Welcome to Get Your FRQ On. This question is from 2001. It's question 6, and it is not calculator active. In the question stem, we're given that a function f is differentiable. The graph of the function f contains the point 3, 1/4, and we are given an expression for dy dx, which gives us the slope on the graph of f for any point x, y. In part A of the question, we are asked to find the second derivative and evaluate it at the point 3, 1/4. So to find the second derivative, we're basically finding the derivative of the first derivative, and we have an expression for dy dx. dy dx is y squared times 6 minus 2x. In order to find the second derivative, I have to find the derivative of this. Notice that it does use the product rule. So d squared y dx squared is going to be y squared times -2. -2 is the derivative of 6 minus 2x. Plus 2y dy dx times 6 minus 2x. And then I'm just going to simplify that. I already have an expression for dy dx. Dy dx is y squared times 6 minus 2x. So if I replace dy dx with that, I'm going to get -2y squared plus 2y cubed times the group 6 minus 2x squared. All right, now I just want to evaluate that at 3, 1/4, so I'm just going to substitute 3's in for all my x's and 1/4's in for all my y's. And eventually when I simplify, even though I don't really have to simplify, I could leave it, I do get -1/8 as the value of d squared y dx squared at 3, 1/4. In part B of the question, we are asked to find the solution to the differential equation y equals f of x by solving the differential equation and using 3, 1/4 as our initial condition. So when you have a differential equation like this, if it can be solved using separation of variables, that is the expectation. For the most part, A/B students wouldn't really have any other ways to solve these types of differential equations, so that is the expectation. In fact, oftentimes on scoring guidelines, using separation of variables is required for at least one of the points, and it may be required for all of them. In other words, if you don't use separation of variables, you're not eligible for any of the points. So it can be solved using separation of variables. We will solve it using separation of variables. All right, so we have dy dx equals y squared times 6 minus 2x. If I set this up for separation of variables, divide everything by y squared, multiply everything by dx, and then integrate both sides. All right, so if I integrate both sides, the antiderivative of dy over y squared is -1/y. The antiderivative of 6 minus 2x is 6x minus x squared plus a constant. If I solve this for y, I'm going to get y equals -1 over 6x minus x squared plus the constant. At this point, I do need to solve for the constant, and to do this, I would use the initial condition, 3, 1/4. So if I just replace y with 1/4 and x with 3, I can figure out what value of c would make this true. And if I do that, eventually I can work it out where c is -13. So the solution to this differential equation using 3, 1/4 as the initial condition is y equals -1 over 6x minus x squared minus 13, or if you like positive numerators for stuff like that, you can write it as x squared minus 6x plus 13. Either way, you don't need to simplify that. Probably not worth it. If you make a mistake, it could cost you. But that would be the particular solution to this differential equation using the initial condition 3, 1/4.